A los humanos le perdonamos de todo.
¿Cómo es eso?
Nos pisan la pata.
Los perdonamos.
Nos bañan.
Los perdonamos.
Se comen un pollo entero delante nuestro.
A veces los perdonamos.
Por eso te digo, les perdonamos todo.
Sí, pero también nos comemos sus zapatos.
Entonces estamos a mano.
Hey, Meta, play gorgeous.
Hey, no, fun.
Thank you.
Might be the number of matches. You want to or add it works out to be a probability of about means to be informative is that it's unlikely. A much more probable pattern to see with this opening would by around 13. So that's
so let's see if they have
cute. They're so
words.
with my friend would 50 from hitting this pattern would.
So when we think about sample set, sample space, we've got a particular pattern on a word. 1, 2, 3, 4. So like this pattern corresponds to a certain subset of the sample space. Just call this V sub P. We'll call it like V sub this pattern or whatever. We say, what's the probability? Still confused between the word is known versus not known. So what's the probability of this event happening? So probability of V sub P. I mean, if we're going to say the probability of a word, that would be 1 over, size of the sample space. Probability of V sub P is equal to. So what are we saying? We have a probabilistic experiment here. We're going to draw a word. What's the probability that the word is in this set? That's really what we're saying. What's the probability that the outcome is in this set? Probability that the outcome, P. Okay. Always think about it in terms of just restarting the experiment, like starting from scratch. Like, okay, we're just gonna today we're playing Wordle, and what's the probability that the word is gonna be in this set? What's the probability of this pattern? What's the probability that the word is going to be in this set? What's the probability of this pattern? Kind of think of the word kind of lighting up different areas of the sample space. We run this experiment many, many times. Just a frequentist interpretation.
see 58 divided by around 13,000. Of course, they're not equally likely to be answers. Most of these are very obscure and even questionable words. But at least for our first pass at all of this, let's assume that they're all equally likely and then refine that a bit later. The point is, the pattern with a lot of information is, by its very nature, unlikely to occur. In fact, what it means to be informative is that it's unlikely. A much more probable pattern to see with this opening would be something like this, where, of course, there's not a W in it. Maybe there's an E, and maybe there's no A. That
more probable pattern. More probable pattern just means it. More probable pattern means it just corresponds to a larger segment of the sample space. So if one pattern just corresponds to like this little part of the sample space, this is like P1, like V of P1, and this pattern here this is like P2, and this corresponds to like this part of the sample space, V of P2, then this is going to be a much more probable pattern. More probable pattern, much more probable event to happen is that the word is going to lie in this event, in this subset.
R, there's no Y. In this case, there are 1,400 possible matches. So if all were equally likely, it works out to be a probability of about 11% that this is the pattern you would see. So the most likely outcomes are also the least informative. To get a more global view here, let me show you the full distribution of probabilities across all of the patterns that you might see. So each bar that you're looking at corresponds to a possible pattern of colors that could be revealed, of which there are 3 to the 5th possibilities, and they're organized from left to right, most common to least common. So the most common possibility here is that you get all grays. That happens about 14% of the time. And what you're hoping for when you make a guess is that you end up somewhere out in this long tail, like over here where there's only 18 possibilities for what matches.
Yeah, you're hoping that you do a guess, and you're hoping that your pattern just matches like a very small portion of the sample space, because like all these words got ruled out. So that's a lot of information if you've narrowed it down all the way that far.
Pattern that evidently look like this. Or if we venture a little farther to the left, maybe we go all the way over here. Okay.
Yeah, so the patterns probably kind of look like this in terms of carving up the sample space. So you've probably got like, this pattern here, which is the most likely one, and then like this one here, which is like the next most likely, and then like this one here, and then you start to kind of like just, carve it up like smaller and smaller and smaller and smaller. With like these patterns out here. Maybe kind of clustering them up. So you have like the top 3 patterns here, which probably take up like at least like 50% of the sample space. So maybe it's like this one's like half, and then this one, and then it's like this right here. This is like the P1, the P2, the P3. And now you've got all the rest of these. We'll say, that again, we have like half here is like this chunk. So you're kind of like carving this up. And then you've got all this like long tail here, which is like all these like small, very like small parts of the sample space. So you do it like this, but yeah.
Here's a good puzzle for you. What are the 3 words in the English language that start with a W, end with a Y, and have an R somewhere in them? Turns out the answers are, let's see, wordy, wormy, and Riley. So to judge how good this word is overall, we want some kind of measure of the expected amount of information that you're going to get from this distribution. If we go through each pattern and we multiply its probability of occurring times something that measures how informative it is, that can maybe give us an objective score. Now, your first instinct for what that something should be might be the number of matches. You want a lower average number of matches. But instead, I'd like to use a more universal measurement that we often ascribe to information, and one that will be more flexible once we have a different probability assigned to each of these 13,000 words for whether or not they're actually the answer.
All right, it's probably a good place to pause. Yeah. Okay. Peace.